When we look at the equation for Coulomb's law, our equation is that F is going to equal K Q1 Q2 all over D squared. A reminder that F is your force of attraction or repulsion, and it would be measured in newtons. Your Q1 and Q2 are your amount of charge on particle 1 and particle 2, and that is measured in coulombs. D is the distance between the particles, and that will be measured in meters. And K is your proportionality constant. It's always the same, and it's 9 times 10 to the 9th with the unit of Newton meters squared per coulombs squared. In a problem like this, we are asked, what is the force between two positively charged particles, one with a charge of 0.05 coulombs and the other with a charge of 0.04 coulombs if they are 0.25 meters apart? When we start with our data, we have that our Q1 is going to be equal to 0.05 coulombs, and our Q2 is going to be equal to 0.04 coulombs. They are separated by a distance of 0.25 meters. Our equation is going to be F equals K Q1 Q2 all over D squared. When we write our setup, we're going to have 9 times 10 to the 9th Newton meters squared per coulomb squared times 0.05 coulombs times 0.04 coulombs all over 0.25 meters squared. When we multiply that out, you're going to come out with a force of 288.0000000. If we put that into scientific notation, it would become 2.88 times 10 to the 8th. Because our original decimal is here, we'd be moving our decimal 1, 2, 3, 4, 5, 6, 7, 8 places. Our original number is greater than 1, so we would have a positive decimal. When we look at the unit in the equation, we have coulombs in the numerator and the denominator, so it would be canceled. We have meters squared here, and you're left with just newtons. So our final answer would be 2.88 times 10 to the 8th newtons. We also know that these are both two positively charged particles, so that tells me that this is a force of repulsion. In our next problem, we have a problem that reads, find the force between two particles, each with a charge of 2.1 times 10 to the negative 6th coulombs if they are 0.5 meters apart. Try this problem on your own for a minute, and then we'll go over it. Going over this problem, we have our Q1 is 2.1 times 10 to the negative 6th coulombs. Our Q2 is also 2.1 times 10 to the negative 6th coulombs, and they're separated by a distance of 0.5 meters. Our equation stays the same as F equals K Q1 Q2 all over D squared. When we write our setup, we're going to have F is going to equal 9 times 10 to the 9th Newton meters squared per coulomb squared times 2.1 times 10 to the negative 6th times 2.1 times 10 to the negative 6th coulombs, all divided by 0.5 meters squared. When you're plugging these numbers into the calculator, make sure that you are just writing them as 9 times 10 to the exponent of 9. If you come up with any error messages, it is possible that your negative sign, you make sure you're using the negative on the calculator, which is underneath the number 3 on your graphing calculators. And when you do that out, you should get a force of 158,759.9 newtons. We're not given enough information in this problem to know whether this is a force of attraction or repulsion.